Welcome back to Rational Functions. This is Rational Functions Part 2, and if you're following in the book, we are still in section 4.5. Okay. What we're going to do is try and continue graphing a little bit more complicated rational functions. So I'm going to just write it, maybe clear the screen, and then we'll write our information on the right side so we can squeeze in the grid. So here's our function that we're going to try to graph today. Y equals 2x divided by x plus 3. Now, if you remember from part 1, we ended up producing a vertical and a horizontal asymptote that kind of framed in the graph. And that sort of thing is going to happen in this graph as well. And there's an easy way to find vertical asymptotes. So we're just going to make a note. How do you find the vertical asymptotes? They're easy because it's where your rational function is undefined, or where it's restricted. Okay? In this case, the restricted value for x here is -3. So guess what? When x is -3, we have a break in the graph. And most of the time, the break is a vertical asymptote. There are exceptions to that, but most of the time, the graphs that we're going to see have a vertical asymptote at the restricted spot. So let me just produce the grid here, and we're going to go ahead and draw that in. So let's see here. I'll try and draw it with a steady hand here. So at -3, we are expecting a vertical asymptote. So I'm just going to draw a dotted vertical line at the location of x equals -3. And again, this kind of frames in the graph here. Okay. Oops. Okay, so I think that's probably good enough to frame it in. Now, what about the rest of the graph? Well, let's construct a little table of values here. And we're just going to kind of work out the y values from the function. So we're just going to take some of these points and squeeze them in here. Let's see, what would be a good point to start with? How about maybe -5? So if we plugged in -5, let's see what the y value would be. So we would get 2 times -5, so that's -10, divided by -5 plus 3, so that would be -2. So we'd get +5. So let's go put that point on. -5 is corresponding to +5, so right about here. Okay. All right, let's try, what about if we're a little bit closer with, say, -4? So if I put -4 in, I will get on the top 2 times -4, which is -8. And that divides by -4 plus 3, or -1. So we get +8. So -4 is up 1, 2, 3, 4, 5, 6, 7, 8. It's quite a ways up there. Okay. Now it looks like our graph is heading up. So I have the feeling this part of the graph is working its way up like this, getting closer and closer to that vertical asymptote. And probably on the left side here, it looks like it's going to smooth out a little bit like that. Why don't we try another point and just have a little look? Why don't we try -6? So we put -6 in for x, we would get -12, divided by -6 plus 3 is -3, so we're getting +4. Whoops. There we go. So -6 is here, and we would be up at 4, so right about there. So I think what we have happening is something like this, and the question is there a horizontal asymptote? Well, more on that in a little while. What I'm now going to do is go on the right side of that vertical asymptote. I'm going to clear away a little bit of space here. See if we can, okay, whoops, ran out of room there. Let's clear off the bottom part. Okay, so what I'm going to do now is continue my table of values, but this time we're going to look at points that are on the right side of the vertical asymptote. So how about something like -3? If I put -3 in, I will get, oh no, I can't do -3. That's where the vertical asymptote is. Okay, get that out of there. How about negative 2? So we would have negative 4 divided by negative 2 plus 3 is positive 1. So it looks like we got negative 4. So negative 2 is down at negative 4. Okay, so down there, let's try negative 1 and see what we get. We plug that in, we're going to get negative 2 divided by negative 1 plus 3 is positive 2, so it looks like negative 1. So we have the point negative 1, negative 1. Okay, so here's what I think I see happening here is this is heading down like this. See if I can draw this right. It's sort of getting closer and closer now to that vertical asymptote. And over here it looks like it's heading up this way, but exactly where? Well, let's try another easy point. What if we plug in 0? We would get 0 on the top divided by 3, which is 0. So we have the point 0, 0. Okay, so it looks like our graph is going through the origin and probably curving up like this. But it looks like there's supposed to be a horizontal asymptote. How do we know? How do we analyze horizontal asymptotes? Well, let me show you how you analyze them. So we'll clear a little bit of room here. Okay, the trick is still to use our table of values, just like we did before. Okay, let's clear up this last little bit here. And what we're going to do is kind of go to extremes on this. Okay, so again, table of values. So let's just look at the right side here. Now, suppose I kept going to the right, and I let my x numbers get bigger and bigger and bigger. Now, I did this ahead of time, and I just gave my answers at decimals to kind of show you. So what I did, I picked 10, and I plugged in 10. So I went 2 times 10 is 20, divided by 13. And as a decimal, that works out to be 1.538, and so on. Okay. Now, let's carry on. Suppose we go way far to the right, and we plug in 100. So I plugged 100 in for x, and I worked out the decimal, and I got 1.942. Okay. Now, let's say I go even further to the right, and I plug in 1,000. When I work that out, I got 1.994. Okay, what should be apparent here is the bigger I make x, the closer the y value seems to get to the number 2. It's kind of like I'm approaching a y value of 2 as I let x get bigger and bigger. And you'd be absolutely right. And what that tells us is that here, there is, as we go to extremes, a horizontal asymptote of 2. Okay, these numbers here, these are approaching, trying to reach a value of 2 the further we move to the right. The bigger x gets, the closer the y value gets to 2. That's how you spot a horizontal asymptote. Now, I don't want to stretch this out too long, so I'll just very quickly show you what happens when we look as we go to the left. Usually, when we go to the left, we kind of get the same horizontal asymptote, but not always. There are exceptions to that. But I went ahead and worked out some numbers, so I'll just show you what those look like. So I would take a look. What if we plugged in, say, negative 10? And what if we went further to the left with negative 100, and then even what about negative 1,000? So this is going to give me an idea what y value we are approaching. And so here's what I did. When I did the calculation, I got 2.857 as a y value. Then it dropped a little bit. When I was at negative 100, I got a y value of 2.062. And finally, my last at negative 1,000, I got 2.006. So what it seems to be is these numbers are kind of approaching a y value of 2 as well, but from above. The smaller we let x get, the further to the left, seems like the y values are getting closer and closer to 2. And that kind of fits with our picture here. So if I put in a horizontal asymptote here, then it definitely does seem like we are approaching a y value of positive 2. Okay, so what does that mean as far as domain and range go, or if you like, kind of limitations on the graph? Well, we have graph everywhere except x can never be negative 3. There's no point on the graph when x is negative 3. And similarly, there is no point for y when the y value is here at 2. There's no point there. The graph never gets there. So these are kind of the two places the graph never achieves, either as a domain or a range. And with that, we are going to stop recording part 2.